Hello, students. I know some of you had a little difficulty with the inclined plane assignment, so I thought I'd make this video to help you guys get through it. So I'm going to have the document open side by side with the interactive lab, so that way it's easier for me to go back and forth and just show you what we're doing. I'm going to just follow the instructions that we have up here. It says set the force of the load to 5 newtons, the ramp length to 1.0 meters, and the friction to 0. So the whole investigation, we're not going to have any friction. So here in the simulation, we're going to change the load to 5, the ramp length to 1, and then we set the friction to 0. We can drag this over here as well. And then step 2 over here says click and drag the crate up the inclined plane until the applied force arrow turns green. The box should slide up automatically when I have applied enough force. So I'm going to go ahead and do that. There we go. It's going to slide up. And now we have our output here. This is the box where we get the information we need to fill in our data table down here. So it says in the data table below, write the amounts of the applied force and the work done in joules in the box for 5 newtons and 1 meter, which is going to be right here, 5 newtons, 1 meter. So our information is going to go here. So the first thing we need is the applied force. So from our investigation, the applied force is 2.50 newtons. So I'm going to go ahead and type in here 2.50 newtons. And then the amount of work done is 2.50 joules. So they're the same number. Let me put that in here. 2.50 joules. That's a little small, so maybe we can make it bigger. Now, save time. We'll just leave it like that. So then it says, click the orange reset button, set the force load to 5 newtons, friction is 0, but the ramp length to 1.5. Okay, so I'm going to come over here, reset, 5. We're going to make the ramp 1.5, so it's longer this time. And then reduce the friction, and then drag it up again. So I'm going to click, drag it up. 1.67 release. There it goes up. All right, now we get our output table. The applied force, 1.67 newtons. So I'm going to type that in here. 1.67 newtons. And then the work done, oh, it's the same as the other one, 2.5 joules. Let's put that 0 here just to keep the consistency. All right. So 2.50 joules, same amount of work done, 2.50 joules. All right. So then it says repeat, click the reset button, set the force to 5, friction to 0, change the ramp length to 2. All right. So the ramp's going to be even longer. I'm going to come over here, click reset. The load is going to be 5, friction 0, and we're going to make the ramp really long this time. I'm going to make you go all the way to 2. All right, so now it's 2. Same thing, going to drag it up here. All right, so our applied force this time was 1.25 newtons. And how much work was done? 2.50 joules, just like before. So let's stop and take a look at this for a little bit. So when the ramp was only 1 meter long, when it was shorter, we had to use more force to do a certain amount of work. When the ramp was twice as long, look, we only used half of the amount of force to do the same amount of work. Okay? So the longer the ramp, the less force we need to use to push it. The shorter the ramp, the more force we need to use in order to push it. So that means if the box is really heavy, it might be better to have a longer ramp. Otherwise, we might not be able to get it up there. Okay. So that's the way this assignment works. Now, for the second part, which I'll go ahead and do the first two here, all we're going to do is now reset, and we're going to leave the load force at 10 newtons, which it already is. And then we change the ramp length back to 1, friction 0, and drag it up. Let's see what happens. So now the applied force is going to be 5.00 newtons. And the work done, 5 joules. 5.00 joules. So let's do a little bit of comparison. So now our box, our crate here, requires twice as much force in order to move it. Now it's 10 newtons. So it makes sense that the amount of work done, 5.0, is twice as much as it was here at 2.5. Okay. So that's the way that this assignment worked, guys. You keep figuring out the applied force and the work done, or 10 newtons, 1.5, and then make the ramp longer. And then the last thing you'll do is change the force required to move the box to 15 newtons. Once you have all that in place, take a look at your numbers, compare like we did up here, and then you are ready to answer these questions down here. Okay? So I hope that was helpful for you guys. We'll see you later.